Good morning, everybody. All right, this is your homework for tonight. It's a foldable on shape, center, spread, and outliers. Now, of these four, we've already talked about center and we've already talked about outliers. The only two new things are going to be like shape and spread. So let's get started. Open up this first flap for shape in your foldable, and you should see this. Now, the definition of shape. The definition of shape is like how the graph or the data is clustered. When it looks like this, where it's got a nice steady rise and a fall, and it's pretty even on both sides, this is called symmetrical. So if it's got a nice center and even on either end of a dot plot, and if its whiskers are the same sizes and the two pieces of the box are the same sizes, this would be a symmetrical box plot. So we have a symmetrical box plot and we have a symmetrical dot plot. Now the next thing we talk about is how things can be skewed, which means like your data is closely clustered on one end or the other. Notice how we have a close cluster here and it goes down there. This is what we call the tail of the data. If the tail is on the right hand side, it is skewed right. And just like the same with our box plots, notice the right whisker is longer. Therefore, it is skewed right. When you're skewed right, it means your median is less than your mean. I forgot to mention that for symmetrical. For symmetrical, it means your mean and your median are the same. So we have equal, less than, well, that leaves greater than. Notice here, your tail on your data is on the left-hand side. So what do you think that would be? Hopefully you said skewed left. Notice the tail for the box plot, or the longer whisker, is also on the left-hand side. This occurs when your median is greater than your mean. Now let's practice identifying. Let's look at our first example here. All right, this is like a little U. What do you think it would be? Hoping you said symmetrical, just the reverse of that. It's like having that, but the opposite. So this would be symmetrical if we were going to describe its shape. Example number 2. Again, you want to notice where your tail is. This is the tail, and it's on the right-hand side. So it would be skewed right. Describing its shape. Describing the shape of this box plot, you look for where the longer whisker is. The longer whisker is on the right-hand side, and therefore it would be also skewed right. All right, for shape, you're going to have to, For shape, we're going to ask that you use these words to describe data. Symmetrical, skewed right, skewed left, and what that could potentially mean. Skewed left, the median's greater than the mean. Skewed right, the median is less than the mean. And symmetrical, they are equivalent. All right, let's go down to center. Now, you guys already know the measures of center. So the definition of center is the center of the data can be described by, now we've been talking about mean, median, and mode. So when we describe center, you're really going to only want to focus on using the mean and the median. So please remember the median is the middle number, but you have to put them in order from least to greatest. The mean is found by adding all the values in a data set and dividing by the number of values, which you already know. So take a second, pause the video, find the mean and median for these two sets, and I'll give the answers in a moment. All right, the mean for the top one should have been 3, median 3. Uh-oh, the mean and the median are equal. If you were going to describe this shape, what would it be? Symmetrical. Good. Example number 2. Your mean is 77. Your median is 80. what do you see? The median is greater than the mean. So if we were to describe this shape, what would it be? The median is greater than the mean. Skewed left. So we can describe this data with its shape as well as its center. Skewed left. All right, on to the next. Outlier we talked about earlier in our lessons, both just yesterday, probably today, and the day before. Definition of an outlier, as you already know, is a value far away from the rest of the set of data. So all we have to do in these data sets is identify the outlier. Hopefully you know that this right here would be the outlier. It is very clearly kind of a lone wolf way out there by itself. Let's do our first example. Identify the outlier. The outlier here would be 15 because the rest of the data is quite higher. Example number 2. Find the outlier. The outlier here would be 40 because all the other numbers are quite small. Example number 3. Find the outlier in a dot plot. If you don't see this one, it might just be because you're not paying attention. This is an outlier. Now, if you were to describe the shape of this data, how would you describe it? Symmetrical. Good. It's symmetrical because it's got a center and even on both sides. The outlier will, however, greatly affect the mean of the data, but not the median. Next, last but not least, we're going to talk about spread. In the previous video, I had discussed spread as the range in the interquartile range. So the spread is actually just another way, or exactly the same as, the range or the interquartile range, which we'll do IQR. Just to give you a little reminder, the range is found by taking the maximum number and subtracting the minimum. And the interquartile range is taking your third quartile, or Q3, and subtracting your first quartile, which is Q1. Just a little reminder, when you have a box plot, what those pieces are. That's Q1. That's Q3. So it's like finding the range of the box. All right, let's practice it. Finding the range of a dot plot. Well, what's its least value? Oh, sorry, we'll start with the greatest since we start with the max. What's its greatest value? Its greatest value is 22 minus the minimum value, 6. 22 minus 6 is, so 22 minus 6 is 16. Now, in example number 2, we're going to find the range and the IQR given this box plot. This box plot shows the math test scores of a 6th grade class. To find the range, we're still going to take the maximum and subtract the minimum. Well, the maximum is there and the minimum is there. So the maximum, I would say, is like, I don't know, 98. So we'll go 98 minus the minimum, probably about 68, which gives us a range of 30. Then the IQR, which I'll use red for, takes the Q1 and the Q3, which I'll match. So Q3, I would say, is probably about 94 minus the Q1, 79. 94 minus 79. 94 minus 79 is 15. Now, we're going to use shape, center, spread, and outliers to describe data today, at least. Well, yeah, your next class. And then after that, we're going to start making inferences using these pieces. So it's important to know what the shape, the center, and the spread all describe. Shape is what it looks like where the data is clustered, normally distributed, symmetrical. If the tail is to the left skewed. If the tail is to the right skewed. Outlier, a number far away. Center, we're going to use and focus on mean and median. And spread are the ranges. It describes how widespread your data is. Is it very, like on a number line, or temperatures, like Henry and Hector's? Is it very varied or widespread, like Hector's was? Or was it not very variable or not very spread out, like Henry's was? So we use the range and the interquartile range. We're going to talk to you guys more about this, but this is just a little head start. Have a great night.